Hey, afternoon, folks. Welcome to Form 2 Mathematics lesson. This class is centered around polygons and exterior angles. It's a presentation by Sparkkk. Please remember to subscribe, like, and share the video clip so that you can grow the channel. Without further ado, let's get into the objectives. By the end of this session, one should be able to identify interior and exterior angles of polygons, calculate interior angles of regular polygons, also finding some of our exterior angles, exterior and interior angles, apply angle rules confidently in exam style questions. Now, things that we may find interesting are definitions of terms like a polygon. This is a closed shape with straight sides. Examples: triangle with three sides, quadrilateral 4, pentagon 5, hexagon 6, you name them. Interior angles. Interior angles are angles inside the polygon. For a regular polygon, when we say regular, it means all sides are equal. Interior angle is calculated as n minus 2 times 180 degrees over n, where n is the number of sides. Exterior angles, an exterior angle is formed outside the polygon by extending one side, such that sum of exterior angles of any polygon, the result will be 360. And for a regular polygon, you can come to say exterior angle, because it's equal-sided, it will be equal to 360 divided by n, where n is the number of sides. Now, relationship between interior and exterior angle at each vertex. Interior plus exterior angle, these are supplementary. In other words, they add up to 180 degrees. So let's try and dive into these 10 problems together. Right, the first one, interior angle of a regular polygon or pentagon. So if it's pentagon, we know it's 5 sides. So our formula says n minus 2 multiplied by 180 all over n, where n is the number of sides. So when we do so and doing our substitution for a pentagon, it's going to be inside the brackets 5 minus 2 all over 5 multiplied by 180. So let's try and do the simplification. 5 into 180 is going to give us 5 into 5, that's 1. There into 15 is 3, remainder 3. And 5 into 30, that's 6. And remember, 5 minus 2 here, we get 3. So when we multiply 3 times 6, it gives us 18, carry 1. 3 times 3, that's 9, plus the 1 we carry, 108 degrees. So it means each interior angle of a regular pentagon is 108 degrees. What about interior angle of a regular hexagon or regular hexagon? So from our formula, it's going to be 6 minus 2 all over 6 multiplied by 180 degrees. And when we do our calculation, 6 into 6, 1 into 18, 3 into 0, so we have 30 there. But 6 minus 2, that's 4. So we end up having 4 times 130. I'm sure it will give us 120 degrees. So it means inside the regular hexagon, we're expecting to have each angle equal to 120 degrees. Exterior angle of a regular octagon. So this time around, we are interested in outside the shape. So it's a regular one. Octagon means 8. So here we are going to divide 360 degrees by 8. And then when we do so, 8 into 36 thing, it goes in 4 times, remainder 4. So 8 into 40, it goes in 5 times. So it means each exterior angle is equal to 45 degrees. Then moving to the fourth one, find number of sides. If exterior angle is 30 degrees, so exterior angle, now if it's regular, then we know we have 360 degrees divided by 30 degrees. So the zeros, they cancel. So this is going to be 12 sides, which is a decagon. Deca, that's 10. So this one is 12 sides. Then moving to example 5, interior angle using exterior angle. If exterior angle is 40, yeah, what about the interior angle? We say they are supplementary, so we can call it x. So in other words, we are building an equation to say 40 plus x, it gives us 180 degrees. Therefore, when I transpose, I have 180 degrees minus 40 degrees. Therefore, here I'll end up having 140 degrees, which will be the interior angle. Still moving on, sum of our exterior angles. A polygon with the irregular sides. Well, sum of exterior angle is always 360 degrees. Complementary angles at a vertex. I think here we want it supplementary. We're saying they add up to 180 degrees, because they will be formed on a straight line. Then for a triangle, exterior angle, and exterior angle equal to, now if it's a triangle, because we're not sure whether it's regular, if it's regular, it's equilateral. So in ordinary triangle, we are saying is equal to sum of two opposite interior angles. Then example 9, regular decagon, the interior angle. So deca, that's 10. So here we have in 10 minus 2 all over 10 multiplied by 180. Then what we do here, there it will cancel. So we end up having 18 times 8. And this will give us 8 times 8, and that's 64. 4 carry 6. Then we have 8 times 1, 8 plus the 6, it becomes 4. So that's 144 degrees as a size of the interior angle. Then number 10, the exterior angle reasoning. Each exterior angle is equal to, and the number of sides is if each exterior angle, so here I'm just picking, well, it can be just a rough angle in size. For instance, if I pick an angle like 60 degrees, for instance, so if an exterior angle is 60 degrees, then number of sides is going to be 360 over 60. So they're going to be 6. I think basically that's what we have from the introduction of angles and polygons. Please remember to hit the like button, share, and subscribe to the channel. Bye for now.